This is a little bit of sections 3.7 and 3.8. It's finding determinants and inverse matrices. To start out with, we're going to find determinants of a matrix. Notice this matrix has perfectly straight lines here. It doesn't have those edges. Okay? That means they're asking you to find the determinant. And we're going to be using determinants later on when we learn Cramer's rule, which will help us to, again, solve systems of equations. So to start out with, a 2 by 2, if we want to find the determinant, you start up in the top left-hand corner with, in this problem, it's a 3. Start in the top left-hand corner, and you're going to take, this is what I usually call the main diagonal. Okay, so starting in the left-hand corner, I'm going to take those two numbers and I'm going to multiply them together. Okay, so it's going to be 3 times 8. And then always in the middle, I want to have a minus sign. Okay, and then the next part, you're going to start up in the other corner on the top right, and if I take this other diagonal, I'm going to multiply those two numbers together. So it'd be negative 5 times 4. And now we do the math. Okay, so we just go ahead and do the math. 3 times 8 is 24. Minus in the middle, negative 5 times 4 is negative 20. And if you want to do a little keep, change, flip, keep the 24, change minus to addition, change negative 20 to positive 20. Put those together, 24 plus 20 is 44. So that's going to be the determinant. Determinants are one number answer. So again, you take the main diagonal, multiply those together, minus the other diagonal multiplied together, and you will get the determinant. Now a 3 by 3 determinant is a little bit different. How I started is I rewrite the first two columns. So I'm going to take this 13, 1, 0, and I'm going to rewrite that out on this right side. So I've got 13, 1, 0. And then I take the second column, and I'm also going to rewrite that one. 4, 3, 1. Now the steps are pretty much the same, except it's a little bit more advanced because it's a 3 by 3. Again, we start up in the top left-hand corner, and I'm going to take this main diagonal. Now we have three numbers to put together. We're going to multiply those. So I've got 13 times 3 is 39, times negative 2 is going to be negative 78. Now I'm going to continue to do the diagonals that go in this same direction. And we're going to put those together by adding them. Notice I started this with a set of parentheses. So now I move over to this one. 4 times 0 is 0. Plus the last diagonal going in this direction, negative 7 times 1 is negative 7. So now I've put all the diagonals going in this direction together, and notice I'm adding those. Now in the middle, we still need a subtraction sign. Okay, so I'm still going to put my minus sign in the middle. Now we're going to do the diagonals going the other direction. And again, we're going to put them together. So we start in the bottom left-hand corner, going up. 0 times 3 times negative 7 is 0. Plus, next diagonal, 1 times 4 times 13 is 52. Plus, the last diagonal, negative 2 times 1 times 4 is negative 8. So I put all those diagonals in that direction together, again, by adding them. Always a minus in the middle, however. So now I'm just going to go ahead and do the math. Negative 78 plus 0 plus negative 7 is negative 85. Minus 0 plus 52 plus negative 8 is 44. When I put this together, negative 85 minus 44, that is negative 129. So again, determinant is a one-number answer. That's how you do a 3 by 3 determinant. Moving on. Oh, there's a fun little joke. Finding inverses. The formula for the inverse of the matrix. Notice this matrix is A, okay? Matrix A, and they just put in A, B, C, D for the elements. Now to find the inverse, notice there's a little -1, A to the -1. That means the inverse of A. If I want to find the inverse of A, first I take 1 over, and remember these straight lines mean determinant, so it's going to be 1 over the determinant of matrix A. This is a capital A. That always stands for a matrix. Okay, so when you see a capital A with these straight lines, that means the determinant of matrix A. Now notice I'm going to multiply that by a new matrix. The matrix over here, notice we've got A, D in the main diagonal. When you rewrite it over here, those are just switching places. Okay, so the D and the A switched places. Now the B stayed where it is, but notice we changed the sign. So that's going to be the opposite. And the C also stayed where it is, except we changed the sign. Okay, so let's put that together and actually find the inverse of this matrix. To make it a little easier, the first thing I'm going to do is I'm going to find the determinant of A, okay, which is what we just learned. So I'm going to start by taking the main diagonal and multiply those together. -6 times -3 is positive 18. And again, in the middle, we always subtract. And then we take the other diagonal and multiply those together. 4 times 5 is 20. So the determinant of this matrix is -2. Now if I want to find the inverse of A, okay, that means A to the -1. Remember from the formula, it's going to be 1 over the determinant, which I found out to be -2, so 1 over -2. And we're going to multiply that by a new matrix, okay? Remember this main diagonal? Those numbers stay the same, except they switch places. So -3 goes in the top left, -6 goes in the bottom right. The 4 stays where it is, but we change its sign, so that's going to be -4 in this position. And then 5 stays where it is, but we change that sign, so that's going to be -5 in this position. So there's my new matrix. Now, -1/2 has become my scalar. So this is a scalar multiplication from this point on. So the inverse of A is going to be -3 times -1/2, which is positive 3/2. -4 times -1/2 is positive 4/2, also known as 2. -5 times -1/2 is going to be positive 5/2. And then -6 times -1/2 is positive 6 over 2, which is positive 3. So this matrix right here is my inverse of A. And that concludes sections 3.7 and 3.8 for now.